Okay, we are starting with the last module of our theory session, that is Introduction to Drone Data and Analysis. Okay, so whatever the we saw in the drones, like payload, like we have RGB cameras, we have thermal cameras, lidar cameras, multispectral, hyperspectral. All this will create different types of images, and which will be useful for you to interpret. But when you see these images, you should able to interpret the data from those images. So that normally is done by the people who are like GIS analysts or GIS technicians, those who are doing photogrammetry kind of activities on the images what has been captured. They create 2D images, 3D images, digital elevation models, digital what we call that DTM, DCM, DSM, surface models, and all the things being created. Normally, these people will be able to analyze data. So basically, this model is not important from a drone pilot perspective, but pilot should know that when we are capturing, like I'll tell you, when we were doing the power line tower capturing, initially the images what we used to capture, those were actually we were flying the drones in a manual way. Okay, so every pilot will have his own way of control on the pilot. So every, like when we are driving a car, no two people are driving the car in a similar way, right? Similarly, no, there are two five people who are flying the drone in a similar way. So when we were actually initially doing the power line towers monitoring kind of activity, we saw that the images what was captured, the data captured by two different pilots was always having some differences there. Okay, so some pilot might be capturing 200 photos, some pilot might only capture 250 photos, 300 photos. Okay, or even when they were capturing the video images, the way the images are being captured by them was lot of differences were there. Okay, so once you have this kind of discriminating kind of data and all this, it's become very difficult for analysis. Okay, drone data and analysis. So we need to have a uniform set of data. Okay, uniform set of way the images are being captured for all the towers and all the things. So then later on we did all the kind of automation, right? Rather manually flying the drone will fly automatically around the tower in a path at a fixed time. It will keep on taking the images. It will keep on taking images, like we from manually we used to capture around 200 to 250 images. Using the automation and all this, we were able to capture almost like 300 to 500 photos. Okay, video size also increased from like 800 GB, 1 TB to approximately 2 TB of videos we were able to capture for particular tower. Okay, so that much huge amount of data was available to us. But then again, manual analyzing of those data was not possible. Then we introduced AI/ML kind of softwares where actually it was able to analyze and prepare the reporting structure of each tower, give the rating to that particular tower, find the faults in that particular tower. All that things was possible using the softwares and all the things. Okay. So table of content, principles of observation, elements of image and video interpretation, introduction to photogrammetry, type of images and video data and analysis. So this is what is the basic. So this is just an introduction to drone data and analysis. This is not in depth topic. Basically, this is just an overview about how the drone data and analysis can be done, just to give an idea to the drone pilot. Okay, so there is a separate module, separate course, which even PFC is working with it. So we are going to come up with a course called GIS Basics and Advanced Courses. We are going to again, those will be 5 days each, but those will be more or less from a theory and practical base. But those are more from a perspective who want to do some advanced activity based on the data what is being captured using the drone. Okay, so those are basically modules. May not be for the people who are not interested in that kind of activity, but those people who are interested in to not only to capture the data but to process the data further and present it to the customers or clients. Okay, or the bodies, like a lot of government organizations are requesting fly the drone, capture the data, and then analyze and give us the reports and all that things. Like I showed you that thermal data which we were doing for water pipeline analysis, right? So using the RGB camera, it was just giving the overall structure. But when we start doing thermal, it was really adding value for doing the surveillance of that power. Sorry, the water pipelines. Okay. So what is the principles of observation? Basically, it is to recognize the target is the key of interpretation and information extraction. Okay, observing the difference between the target and their background involves comparing different target based on any or all of the visual elements like tone, shape, size, pattern, texture, shadow, and association. Okay, so there itself there is a basically there is a topic what we call as image interpretation. You know, at MSc level of geoinformatics, there is a topic. There is a each semester one there is a module which has two books dedicated only for image interpretations. Okay. So here we are only talking about couple of slides. Okay, whereas they have in detail, how to process the images, how to generate the reports from that images, how to generate the differences or find out what are missing, what is wrong, what is right. All that things based on the tone, shape, size, pattern, texture, shadow, and association with the help of softwares. Okay, so if you see here from the tone, like here you have a grayish image. Okay, so refer to the relative brightness or the color of the object in image. Generally, tone is the fundamental element for the distinction between different targets or features. Variation in the tone allows the element of shape, texture, and pattern of object to be distinguished. So here you can see the image. Different ground will give you different color or variation in the tone, right? You can see here the road is going, and then you can see some what is the field is there. There is different open field is there. Trees are there. All that things you can see here, or you can see some certain structure of trees are being made here. So depending upon image, like image to image, it will vary and change. Okay, so this is just an example to give you what you mean by tone. Okay, so variation in tone allows elements of shape and texture and pattern of object to be distinguished. Okay, shape. Shape is again based on the image, we can make out the shape, right? Straight edges shapes typically represent urban or agriculture field, while the natural features such as forest edges are generally more irregular in shape, except while man has created roads, clear cuts, farms or cropland irrigated by rotating sprinkler would appear as a circular shapes. Okay, so refers to as a general form, structure or outline of an individually object. Like here you can see that could be some jogging track or something like that would be there, or some ground is there which has been developed for like some kind of exercising field or some kind of a field for doing day to day jogging, walking track, or cycling track would be there. We don't know what could be that, but looking at this image, I can make out that there is a road. There are some roads, some houses are there, or some structures are there. I can make out from based on the shapes. Okay, again patterns. Patterns to refers to as a special arrangement of visibly discernible objects, typically in orderly repetitions of similar tones or textures, will produce a distinctive and ultimately recognizable pattern. Orchards with evenly spaced trees or urban streets with regularly spaced houses are good examples of patterns. Like अगर कहीं पे कोई society बना है, community बना हुआ है, या lot of row houses are there, or even the trees are planted like banana tree का plantations आप field देखोगे, banana farms or mango farms you will see there. You will see the trees have been planted in a patterns. Okay, so those patterns will give you some discernible objects to understand. Typically in orderly repetitions of similar tones and textures will produce a distinctive and ultimately recognizable pattern. Okay, size of the object. Like if you see this particular image, you can see there is a big warehouse in the center, and then there is a road surrounding it, and then you can see other side of the road there are a lot of small houses are there, which are maybe a residential area for people who would be working in this kind of big structure, a factory or a warehouse which was there. Okay, so people would be working over here and people would be staying next to that in small houses and all the things. So basically size gives us a function of the scale. It is important to assess the size of a target relative to other objects in the scene as well as absolute size to aid in the interpretation of that target. A quick approximation of a target size can be direct interpretation to the appropriate result more quickly. For example, if an interpreter had to be distinct zone of land use, identified area, building large buildings such as factory or warehouses, would suggest a commercial property, whereas small buildings would be the residential use. As I said, this could be a warehouse and this could be the residential houses for those people who would be working in this warehouse or this factory for profit. Okay, texture will give you, like if you see these images, you can see based on this image there are a lot of forest area over here. There would be a grassy land on the top, and then this is like open barren land where you don't see any kind of a vegetation, tree or any grass or anything grown over this. Okay, the smooth textures are most often result of uniform even surface such as field of asphalt or grassland. A target with a rough surface and irregular structure such as forest canopy result in rough textured appearance. So you can see here, this is a forest area, right? There's a lot of trees you can see over here. Okay. So texture is one of the most important element for distinguishing feature in radar images. So normally these type of images are captured using satellites or radar imagery. Shadow again depending upon the way you have captured the image, from what time of the day you have captured. Like when we were doing the power line tower surveillance, we normally used to see a lot of time, morning photos what are being captured, the tower was in a different way was visible. When the tower was captured in the afternoon, the visibility of the tower was different. In the evening, when we are capturing the same tower, the visibility of that particular tower was different. So depending upon the time of the day, the shadow and the light effects used to give you a different perspective of each images. Okay, so depending upon what images you have captured and the shadow effect what you get, it helps to interpret as much as information from profile and relatively height of a target or targets, which may make identification easier. However, sometimes even shadow can eliminate a lot of like this building. If there is something here nearby this building, where the shadow is falling, that image, like if you see here also, that black part, you can't see what is there actually. Okay, it is a completely dark. You are missing the data over that point also. So sometimes it is helpful, sometimes it is also eliminates the interpretation of the area or interpretation of that particular target also. Okay. So sometimes it is beneficial, sometimes it is not beneficial also. So shadow is also useful for enhancing and identifying topographic or landforms, particularly in radar images. But then it is not only, see here we are only seeing one photograph. We may have to have multiple photos from multiple angles. And different time of day you have to capture. So you have to continuously fly the drone and capture as much as possible the data, and then you are able to recreate the entire image or entire structure over there. Okay, association takes into account the relationship between the other recognizable objects or features in proximity to target of the interest. The identification of the feature that one would expect to associate with other feature may provide information to facilitate identification. In an example, if you see the example over here, the commercial property may be associated with proximity to major transportation route. Okay, so you can see there might be some commercial properties are there. Then you can see this is a road. Okay, and then you can see whereas residential area would be associated with the school and playground. So this would be a school and playground would be there. In our example, you can see a lake is associated with boats. Okay, you can see this is a lake and there are certain boats are there. So marine and the adjacent recreational land is available. So depending upon what image you are seeing here, based on that you can interpret the data point from that. So it is association with respect to here with the lake, okay, and the road and the boats and the surrounding area what we can see in the image. Okay, so there are different types of image and video data. Like we have seen these, all the images what we have seen is all about the RGB images. Okay, then we can also have infrared images, near infrared images, night visions we can have, thermal images we can have, multispectral images also. So let's see what are different examples. Okay, so this is like an infrared image. Okay, this is in a grayscale mode. That's why we are not able to see the color. But this is a grayscale infrared images. We can see the person holding the hose pipe. It looks like some kind of a python in his hand or something like that. But this is actually an image where the firefighter person has holding the hose pipe in his hand. Okay. Then you can see near infrared images. You can see two images, same images from the two locations, same location. One is in RGB format where we are not able to interpret what is what. It is just a normal image what we see through our eye. But if you see from a near infrared images, we can make out the NDV features about it. Okay, so we can see what are the color codings are there and all. Based on that, the people can interpret and give you the output what is what and all. Okay, again thermal images. We have seen this type of image also in earlier slides. Okay, where we can see difference in the temperatures have been captured and the image is being created. Okay, then you can see multispectral images. So in multispectral, see this whatever normal apart from the center part, you can see the normal image of the crops or the fields. But when you get the image in a multispectral, you will find out where the crop is grown, where the crop is not grown, or where the land is just lying as a barren land. Okay, if you see from this particular small field of farm, they have estimated and you found that there is some area in between where the crop is not grown properly or there is some issue is happening. Okay, so this reddish part what you see, the difference in the color. Now, normally if you see this here, if you see this particular part, in this green area you can't make out anything out of it. But when you have a multispectral image like this, you can find out the change, the difference. You can find out that this particular portion is having some issue in the growth of a crop. So you can identify this location and find out what is the issue. If there is any requirement of spraying the pesticides or anything is required to be done to correct that, we can timely do the correct. Rather नहीं तो क्या होगा यहाँ पे suppose pesticides ने effect किया है, this particular crop area is damaged. Probably by the time we identify entire thing, तो पूरा farm को crops destroy हो सकता है or would require to spray. And rather spraying the pesticide to complete farm, I can only focus on this particular area to spray the pesticides. Right? So rather utilizing huge amount of pesticide, I can utilize only small amount of pesticide for a small part of area because now I know where the actual problem is. Okay, that's how I can reduce or save unnecessary expenses in maintaining the crops. Okay, again this night vision, this normally is used by military people or surveillance people who use. So night vision will give its own perspective of understanding the image. Okay, so now introduction to photogrammetry. Photogrammetry is a science and technology of obtaining special measurements and other geometrical reliable derived products from photographs. So photogrammetry is not new. Okay, earlier photogrammetry was done using the hard copies of the images. Okay, so optimizing approximate distance, areas, elevation using hard copy or photographic products with unsophisticated equipment. So it was very tedious job earlier. But by utilizing the digital concept, geometric concept of generating precise digital elevation models, orthophotos and thematic GIS data. So digital photogrammetry is changing rapidly and forms the basis of the most current photogrammetry operations. So because of advancement of technology and digital photogrammetry was available, now the photogrammetry has evolved a very enormous way. It has come up as itself as a subject of study, subject of different people are adopting and people are doing a lot of courses. There are a lot of courses available for this particular, like GIS data, GIS analyst, all that new roles have come up where people are doing the courses and doing and learning to understand how the study the photographs and data generated from the GIS data. Mapping from the aerial photographs can take numerous forms and can employ either hard copy or soft copy approaches. Orthophotos combines the geometric utility of maps with the external real-world image information provided by the photographs. The process of creating an orthophoto depends on existence of reliable DEM for the area being mapped. So these are some advantages of now digital photogrammetry. So like I said, like earlier, power line tower board was sending a person with DSLR camera to take the pictures, but those pictures were taken from the ground. A lot of time the images were at angle, they were not clear, they were not sharp. They used to come back once they have done the survey of the tower and then they used to come next day back to office. That time they used to download all the photographs and then they used to see, and then they came to know that whatever photos they are captured maybe not good, not good, proper, or not having much of the right data and all the things. Maybe they have to revisit the tower again and capture the data again, or maybe the timing of capturing the data was not good at that point in time. The sunlight was not feasible for that particular angle and all that thing. So lot of challenges were there earlier. So now after having the digital images and all that things available, and you have a number of photographs more drones, and drone used to fly at the height of the tower itself, so you can capture very close images of the insulators. Especially the challenges was capturing the insulator images. So those were very high, almost like 40 feet high. That was very difficult for to capture from the ground, though you are using zoom lens and all that things, but it was not giving you right image something. Whereas the images what was captured by the drones was very effective and very useful in interpreting the problems at that particular location. So drone data analysis, the image gathered during the mission can be processed using the software. As I told you that whatever the data we used to capture using the drones, initially we tried to do it manually, but then it was a very tedious task and complex task to do it manually by people. So we have to use software to sort, organize and manage the data containing within the image. Okay, that means we want to find out if the nut bolt is missing, member bar is missing, if bird nests are there, okay, or danger plate is missing, number plate is missing, barbed wire is missing, vegetation has grown around the surrounding the towers, whether the insulators are chipped or broken, or insulator has got damaged, okay, the wire has become oxidized. All these points were analyzed using the software. So image processing tool then produces the final data set that can be easily analyzed and provide valuable business insight, such as severity of damage. Like for example, wind turbine का example लिया है, like damage, wind turbine भी damage होता है a lot of time. Degree of degradation of insulators, like I told you, right? Degradation of insulators on power line towers. If the desired data can be turned into 2D, or like, eventually when we completed the project, the board was talking about creating a 3D images of each tower. So in real time, once you have the image data, you have a complete 3D image of the tower itself. Okay, 2D or 3D photogrammetry engines to provide orthomosic maps, digital surface models, or contour maps were also available to them. Storing and analyzing drone data for every mission allow end user to easily make comparison over specific time frame. Example includes the progress of a construction site. I gave you the example, like first tower one, when we are actually monitoring the building construction of a building. I can start taking from the day one, like digging the ground, then laying the foundation, then the first floor, second floor, third floor, like that. We can take the images and store and share it to the stakeholders or the body or executive council to see the progress of the construction site and all the things. Okay, so specific location, incremental degradation of wind turbine blade also, like over the period of time we can see that how like especially like in a geographical data kind of thing, like a lot of time the rivers, they change the course, or their course becomes wide or small depending upon over the period of time. That can be seen when you have a recurring images captured for that particular area. A final report can then be generated to share with the key stakeholders or decision maker to review and take further action if needed. So that is what we normally present under the drone data analysis by the analyst based on the data what is captured by the drones. Okay, so way to view the drone data depending on the software you utilize. There are 100 softwares available. Good software like Pix4D is there, photometry softwares are there, drone deploy softwares are there. Lot of softwares are available which actually captures or interprets the data what is being captured by the drones. Okay, so depending on the software you utilize, you should be able to view your data concisely in a following ways. Like you can generate reports, reports exports using CSV, PDF, charts, graphics and tables. Do analytics also on those images, including performance figures, orders, missions, inspection, flight, pilots, data. Like as I told you, when we were flying the drones manual way, for one particular tower, my pilot used to take approximately 30 minutes of time. Okay, 30 to 40 minutes of time to fly the drones. So he has to multiple times he has to fly the drones and capture the data. Whereas when we automated our flight plan and everything, within 10 minutes we used to capture the entire data of a particular tower. So in a day जहाँ पे हम लोग 10 to 12 towers we used to complete, we were able to complete somewhere around 20-25 towers in a day. Okay, so that's how it has enhanced my time frame. Okay, the amount of capturing the data, amount of flying my drones in a smaller, like manual fly कर रहा हूँ तो मैं अपने हिसाब से manual fly कर रहा हूँ until unless I give throttle up, pitch forward. Again, see the flying the drone near the tower is also a different way because tower is at an angle. Okay, base बड़ा होता है और ऊपर जाके वो hunting में ऊपर short हो जाता है. So you have to fly uniformly near the tower. नहीं तो क्या होता है आपका वापस images छोटे बड़े हो जाते हैं. Images can be in a different sizes. So you have to maintain that distance from the tower also uniform. So that is not possible in a manual flying. So we have to define a flight plan. तो हमको उसके लिए स्पेशली सॉफ्टवेयर में डिजाइन करना पड़ा फ्लाइट प्लान सो दैट फ्लाइट प्लान आई कैन अपलोड into the drone and then drone will follow that particular flight plan and then it will actually generate and capture videos as well as photographs. So there was huge return of investment so that you can track efficiency, safety benefits and program this. As I told you that in power line towers because of the outage there was a lot of revenue loss was happening but by doing the drone analysis, drone missions we were able to bring down the issues what was there and causing the outages of the power line towers which was helping them to reduce the outages and the power line was available for the location. Like for example अगर समझो आप आपके लोकेशन का पावर चला जाता है एक दिन के लिए 2 दिन के लिए 3 दिन के लिए what will be the impact? It is not only the revenue loss to the revenue board also but it is also lost to the people who are staying in that area also because they are not able to function things on day-to-day basis whatever it is like maybe businesses may not be working that particular locations like schools, colleges, classrooms, even small businesses they may not work at that particular time so there is a huge loss not only to the board but even from the society perspective also okay or the location perspective like the power line tower down hota hai, so maybe 10-20 villages may not be getting a power for next 3-4 days. So there is a huge loss. People may not be working. People think abhi power nahi to kya kare. We'll just motor pumps may not be working in the field. People who are working in the villages or small towns, schools, all the things were not working that point in time. So there was a huge loss not only to the board but even for the people in those areas. So that was a complete economic drawback for us. Okay, so by doing this particular project, we were able to control that outages and all the things, and then it was a really huge return of investment, which they saw the benefit of setting up the drone team and regularizing this activity. So earlier, what we did was a POC activity, right? But then later on, they said that we will set up the team, we'll purchase our drones, and we will do all this activity, on our own. So there are lot of our pilots who were there with us on a contract period, they hired those pilots as a full-time employees over there because they were local people over there. Okay, so even there was offer made to me also to join the board and all the things, but then I, being based out of Mumbai, I didn't want to move to that location and all the things. So I said no, I'm good for my own projects and all the things. Okay, so like that you can see it was a lot of benefits are coming. Data mapping, navigation using graphical user interface to navigate across 2D, 3D models. So as I said, they were talking about creating a 3D model of whatever the data capture. So you can create a really 3D model of a particular tower and see it in a real-time 3D view of the entire tower practically. Okay, that was possible by having amount of data what you have captured or videos what you have captured the drones. Okay. So with that, we complete our topic of introduction to drone data and analytics. This topic is a very vast topic. I mean, itself, like this topic is normally taught at MSc level. Okay, MSc Geoinformatics has this topic called image interpretation. Okay, so this topic in itself is a huge topic. It's a semester 1 topic, and it requires at least study of 3 to 6 months of detailed study. Then only you will able to make out a lot of things from this particular module itself. DGC has introduced because they wanted to make sure that future may this will be very important and useful because this people have lot of adoption of drone and capturing the data and then doing the analysis and then presenting to the various executive boards and all the things, and finding it very really useful in saving the time, money, and efforts what we were doing currently traditionally. As I said, power line towers, pehle, the way that traditionally they were able to monitor and all the things, lot of things they were not able to do it. Okay, over the period of time, and there were a lot of outages. Even the forest area में जहाँ पे से टावर जाते हैं वहाँ पे तो बहुत मतलब outages और damages होता था because of unreachability or not monitored on timely basis, and then local issues काफी होते थे वहाँ पे, like people used to remove the metal bars also from the towers. Okay, so a lot of time that towers were damaged, number plate लोग चोरी करके लेके जाते थे, because that is a metal, so it is all the things, barbed wires, vegetations also used to have a lot of problems, and then birds, animals like monkey and all the things also used to cause a lot of damages to the towers. So, lot of monitoring is required for these towers on regular basis. If you then monitor properly, then they will give you error free or outages free kind of service to the people. Okay, so with that we complete our